For programming, we have to look at habits and things that you have to look at when you want to learn to program. Programming skill is something you have to develop. There's practices that you have to learn and you have to apply to. Most people have, when they design programs, is wishy-washy. Half the times the programs don't even work, and they waste more time trying to figure out the program because they haven't developed the skills to learn how to prevent waste of time later on. By this, some people jump into a program, start writing the code, and start punching it in and have 50 billion errors because they don't understand the structure. The best way of doing a program is to, first of all, you get your idea, write your idea down, write the pseudocode. The pseudocode is basically a general approach to how you're going to program the whatever you're trying to design. Then, after you have the pseudocode, then you actually do the coding. From design is the first stage, pseudocode is the second stage, third stage is the actual instruction code. Then even advanced programmers will actually, even before typing it in the computer, will run the program manually. They will pretend they're the computers, run through the instruction codes and see the output and pretend they're following through each instructions and put the output on paper even before they start typing anything in. Those are good skills for development of doing a program. Jumping on a program doesn't make sense. They're going to spend more time. If you do that, when you finish and you type it in, the program should work. The only error you may have is syntax error. Syntax is the language instructions or whatever language that you're programming. But this is the general way that you do for designing programs. Now, if we look at a language, for example, if you want to design, or let's look at an idea if you want to design. Let's just use an idea, for example. Say we want to do a simple program for calculating, typing in people's age and see if they can drive. Let's say it's a program you want to design. You want to think, the idea is to write a program to determine if somebody is at the lawful age that they could drive or get a license or drive a vehicle. So how do we go about? That's the idea. Now the pseudocode, we have to figure out what is the pseudocode we have to design. The pseudocode, for example, is that we need to write down, this pseudocode is basically a general program, not details, but just general things of what we have to do. What is the first thing we have to do? First thing in the pseudocode is get information from the client. So we mark get information from the client. What is this? We need to get their name, we need to get their date of birth, or we can get their age, alright? And this is the information we need from the client. Then what do we need to do with this information? Once we get the information, we have to calculate. If they give us the date of birth, then we have to use a formula to calculate if they can drive. Most places, like if we're in Canada, is 16 years of age. So you have to figure out from their date of birth, right, if they're at least 16 years of age. If not, you could determine, if you don't ask that question, you ask them how old they are, then you would determine from, they would put it like 16 or 17, or if they put 12, then you know how to respond. Well, sorry, you cannot legally or lawfully drive because you're underage. So all these pseudocode you have to write down. You write it down, and then after you get the information, you got to output and tell them, sorry, you can't drive. Yes, you can drive. So all this is the, now after you got the pseudocode, which is the general programming of what you have to do, then you go and start coding detail by detail by detail by detail. with the instruction code of whatever language that you're programming with. Then you're going to go and say, okay, let's rewrite it down. We're going to go now and go through it. First one, it says input the client's name. Okay, let's input. Yep, somebody types in name, input their age. We got the age. Now we have to check to see, make a condition statement. If their age is equal and greater than 16, then print yes, you are lawfully allowed to drive. If then means else statement, you cannot, then you print in sorry, you're underage. That's your whole program. End of program. So you have to look at those scenarios of the concept, the pseudocode, the general programming, and then the detail, and then run the program through your trace table. Actually, I forget, we call it trace table. I'll trace the program to see how it's supposed to perform. Put your data in, pretend you're the computer, before you actually go and type the code in. Now, there's a few things in program. That's a short little program we just talked about. When people are writing programs, there's certain codes of writing program. And there's something called a comment statement. When you write a program, you want to properly document the program. If it's 2-line, 3-line program, it's fine. But if you document it, when programs become thousands and thousands of pages, and they're huge, even if they're 10, 20 pages, even if they're 2, 3 pages, if you document the things using a comment statement, it becomes easier for you to understand when you go back in, or for other people to examine your program. They know exactly what you're doing. Comment statements you place above the things. For example, they will be at the beginning. You put your name, the type of program you're doing, or what the program is about, and the date and all this kind of stuff. And then each section, you comment each section with a note that this is the input section. This gets data from the client of their name, their age, and then the next section of calculation. This section does the calculation based upon the input that you got. This section does the outputting. So it's nicely documented. Now there's also a code for writing your instruction, when you're writing the program in the computer, when you're typing in the instruction code, there's an indentation. Indentation is very important. Some people, the computer will work whether you indentate the instruction or not, it will still work. It doesn't care. But for us, for clarity, it's good. When you begin a procedure, a subroutine, a procedure, a section, you start off at the left side. And when you're doing the instructions inside the procedure, like the word begin, and some have beginning and an end, they stay at the very most left. All the stuff gets indented. The next instructions will go in about, you can put 4 or 5 space. Then the next set will go 4 or 5 space. If you have an if condition, you'll mark if, and whatever the condition is, then, and then underneath, whatever you want executed will get indent another 5. And then the else will be lined up with the if. And underneath the else, there will be indented 5 space, whatever the else condition you want. And the end to the if then statement would go back to line up with the if, the else, and the end will all line up together in the same column it starts with. This, so when people see a program, they said, this is a professional programmer, because they've properly indented spaces. It makes the clarity is very easy to read, and they've fully documented using the comment statement that people know, okay, this routine does input, this routine does calculation, this routine does outputting, this routine does whatever that you design your program to do. If this outputs to the screen, if this opens windows, if this does color graphics, if this does music, all that stuff is documented inside. This is comment. The word they use is documentation, but it's used through a comment statement. Comment statement in some languages is a semicolon, some is an exclamation mark at the very left, and anything after that is not executed. It's just written text of explanation of it. So document your program, indent your program. These are the best structures that you can. If you go to university and college and you don't, they fail you. If the teacher sees you did not indent your stuff, did not document, you fail automatically. They stress more on documentation and format, because in the real world, when you work on the module or a section, you may not work on the whole program. You write a certain section, you pass it on to people, and people have to understand what you did. They have to be seeing the comment statements that you have documented, and they're going to see the indentation so they know. And another reason for indentation is when you end up getting nested statements. There's so much, sometimes so much things, beginning and ending of different routines. After a while you can't even figure out. It's so confusing because the program is so involved that the only way to know is because of the indentation. Where the major group is, and where the subgroup is, another subgroup, another subgroup. It makes it clearer for you to do. So those are good housekeeping for programming to do. Can anybody program? Yes, anybody can sit there and program. It starts with the idea, the concept, and then learning the instruction. Now we have to talk about learning the instruction code. If you want to learn the basic language, you've got to get the book, the manual, and start reading and learn the instruction code for that language. You want Visual Basic, you've got to learn their commands and how the syntax is to execute those instructions. Pascal, Fortran, Cobalt, the same thing. All these instruction codes have to be executed efficiently and properly. A simple comma, a simple bracket, all that stuff leads you into error. The language Cobalt is so precise that people get so much errors because each statement ends like an English statement with a period. If you forget the period, it messes the whole program up. Some of them use period at the end. Some use semicolon at the end of different. I'm trying to remember if it's Pascal or which one uses a semicolon at the end. So different languages have different syntax. Learn the language, learn the syntax, and program is easy and fun. You can design from graphics, the games, the business. People pay people for designing application work. All that stuff can be designed once you learn the syntax. A lot of good programmers, what they will do, if they're going to design everything in Visual Basic, for example, they'll create a lot of routines. We call these subroutines to do many different jobs, and they save them in an archive library. So when they get a job to design, like for example, there may be a routine to output them. There may be a routine to grab data. There may be a routine to parse, to divide numbers. To divide letters. If you have somebody's name and you want to divide each letter up from the input data, there's a routine for that. They call them parsing. So you could divide each letter up. If you want to do things for a counter, you may have a routine. If you have something for a clock routine, you may have all these stores. So when you get a job to do, and you start designing the pseudocode, and you say, okay, yeah, no problem, let's do this. I already have all these. When you start to do now the actual instruction set, right? You're gonna start writing it out, and when you start typing it in the computer, you're gonna access all those subroutines that you already have saved up. You just have to bring it into the program and start using it. So it saves you time, and you make more money because time is money. So these are some little hints that you can do. Now in designing, we're going to talk about analyzing the problem. A customer comes in to you and it says, well, I've got a problem. A program starts with a problem. If you're in the real world and you're working for a company, right, they come up to you, we've got a problem. We need this design. You have to be able to ask the customer, whether it's the people you're working for or whether it's customers that come in from outside to design something, you have to ask valid questions. You have to understand, you have to actually get in their head and figure out what exactly they want. Because a lot of people don't do that, and they waste hours and days and weeks on programming, and they bring it back to the customer and he says, well, this is not what I want. And all that you don't get compensation for. So to avoid waste of time, you have to ask the people specific questions. And you have to make sure you ask them back to see if they understand, and you're telling them exactly what they're wanting, and you describe that information to them. So make sure your questions are precise. If you have a client, ask them the question. You could, for example, let's look at somebody coming in and they want a program design. So you're going to find out exactly, the type. You're going to ask them what type of computer do they have. You got to find out if the computer is powerful enough to do what they're trying to do. Maybe the computer may need additional. If they want to have some security monitoring system, they need to have cameras that's interface with the computer. Do they have these devices? Do they have IP address boards so you can monitor? If they want monitoring off, you have to find out. Ask them the question, do you want this monitoring to be done by somebody sitting down all the time in one location at one computer? Do you want this thing to be monitored through the internet? Do you want this thing to be monitored on various different PC? Then you have to get involved in networking. So all these things you have to ask the people questions like those. What exactly, what hardware they have, what the needs are, and the software design is for what type of clients. What is their customer base? What do they want? What do the customers? What do you want from the customers? Do you want information, the name, the date of birth, the social insurance number? Do you want information about the cars or the house? If you do an insurance program, do you want information about their financial situation, or the children? Depends on what you design. You design a marks program, you have to ask all the types of criterias that they have, all the types of tests that they have, what percentage are the tests based upon, how many tests are in which semesters or which term. All these things have to be determined. All those things you have to find out from your potential client. You have to be specific, and a lot of times they have an idea but they don't know exactly some of the things. You have to come up and tell them, by the way, you need to have this or you need to have that. And they said, oh no, I didn't think about that, or I forgot about it. He says, yeah, that's why you have to tell them. And then you have to ask them, how do they want the data to show up on the screen? This is one of the hardest areas. You have to draw some layouts and says, do you want your information to go on the left side of the screen, the right side of the screen? Do you want your company logo to appear on the top, the bottom, the name of the company, the address, the phone number? Do you want how the boxes to look like? Do you want graphics? Do you want color? Do you want this? Do you want that? All those things you have to jot down and draw screens layout of all the screens, from the input of the data screen, from the menu system, from the output. Maybe you only want certain things to be accessed by the workstations, and you have other data only had by the management. All the stuff you have to find out. If they're going to access, the customer can access through the internet. All those things you have to know if you need networking. There's a lot of questions involved, a lot of thinking. You got to overthink things that the customer doesn't think about when you're designing a program. All that is involved. It's no joke to do, but if you do your job right, you have less problems when you finish designing. So even one advice is, even before you start programming the data, once you've got all this information, create your pseudocode, and then go back to the customer and say, Mr. or Madam, this is the story. This is my code. The idea is we're going to look at XY stuff. This is what the screens would roughly look like. This is what we're going to input. We're going to ask the customer for. This is what we're going to output. This is what we're going to do behind the scenes. And if your customers say, yes, we like those things, this is good, then you do the instruction code. Once you finish doing the instruction code, you do some test run. As I said, pretend you're the computer, do some test run, and then program it in the computer and debug everything, means solve all your errors, and then go to a test run with your client. Say, this is what we've done, and then you gotta keep in mind the customer, even though you did all of the stage, they're still gonna say, well, I don't like this, maybe move it over 5, move this up a little more, move it down. All that is to be expected. Don't get mad, don't get angry, because this is part of the game. The customers are always going to come up with little changes, and then they said, oh, by the way, can you add this little thing in, can you add? I said, man, you should have told me you wanted this little thing. We didn't think about it, but it's going to cost me another week of programming. As long as you're aware of that, then you're going to, people always come up with that. So these are things to keep in mind when you're programming. It's not an easy job. The job is a job, a job. Alright, so you have to be aware of that. And in programming, you have to have patience. If you don't have patience, don't get into programming. Programming requires patience. You have to learn learn the instruction code, learn to analyze, learn to figure out, learn to anticipate your client's needs that they didn't even figure out. So all these things have to be done when you program, even before you get in the field. So master your language set and master all these instructions. With these things here, this will help you to become a more effective and very successful programmer. Thank you very much for your time. Have a great night.